Okay, question 6 says, consider the linear function f of x, which is equal to 2x plus 1. And here we're restricting x to be greater than or equal to 1 and less than or equal to 3. And our job in part A is to graph the function. Okay, so as we've seen in some prior examples, one way to go about that is just to use the y-intercept, which is 1 in this case, and the slope, which is 2 here. But since we are restricting our values for x, another way to do this is just to plug in these endpoints. So in other words, plug in 1 for x and 3 for x and find the corresponding y value outputs. Then just plot those 2 points, and since this is a linear function, we know the graph will just be a line segment, so all we'll have to do is just connect those 2 points. All right, so let's go ahead and find the corresponding y value outputs here. So if I input x equals 1, I'm going to get 2 times 1 plus 1, and that's just 2 and 1 is 3. And if I input 3 for x, I'll get 2 times 3 plus 1, and that's 6 and 1 is 7. Okay, so I'm going to just plot these 2 points and draw the line segment between them. And I get this picture right here. Okay, so for part B, it says, what's the domain and the range of this function? Well, recall that the domain is just the set of all values for x that we can input into this function. And so given this restriction right here, the domain is the set of all x such that x is greater than or equal to 1 and less than or equal to 3. And notice here from the graph, you can see that if I project this line segment onto the x-axis, I'm going to be covering this interval from 1 to 3 right here. Okay, now for the range, this is the set of all output values. So in other words, the set of all y values along our line segment here. So if I project this line segment onto the y-axis, I'm going to be covering this interval from 3 all the way up to 7. So our range here would be set of all y, where y is greater than or equal to 3 and less than or equal to 7. So that would be our range. All right, now part C says find the inverse of the function and then graph it on the same coordinate axes used in part A. All right, so let's go ahead and start by finding the inverse as an equation. So for our function f, we have that y is equal to 2x plus 1. So then for the inverse, we swap inputs and outputs. So we get that x is 2y plus 1. And then I'm going to go ahead and solve for y. So subtract 1 from both sides. And that'll give us x minus 1 on the left and 2y on the right. And then go ahead and finish by dividing both sides by 2. And so we get that x minus 1 divided by 2 is equal to y. So I'll write this final answer in function notation. This would be f inverse of x is equal to x minus 1 divided by 2. Okay, now our job is to graph this function on the same coordinate axes. Okay, and I would say the easiest way to go about that is just to use the fact that the inverse is just swapping inputs x and outputs y. So I'm going to just create this little table over here. So x comma f inverse of x. And for the inverse function, the outputs for f become the inputs for the inverse. So in other words, I'm going to have the inputs now of 3 and 7, and then the corresponding outputs for the inverse are the inputs for the original function, so 1 and 3. And notice we can check that if I input, say, 3 for x into my inverse, I actually will get 1, And likewise, if I plug in 7 for x, let's just, as a little check here, verify that that does work. So if I input 3 for x into the inverse function, I'm going to get 3 minus 1, and then divide that by 2. 3 minus 1 is 2, divided by itself is, in fact, 1. So that's doing what I would expect it to do. And then if I input 7, I will get 7 minus 1, all divided by 2, and that's 6 divided by 2, and that is 3. Okay, so just like the graph for f of x, since I have these 2 points now on the graph of the inverse, I'm just going to plot those 2 points, and this is a linear function again, so I'm just going to then connect the dots, and we'll get this picture. Okay, and you can see as we observed back in section 13.3, looking at the graph of the function f and then the graph of its inverse, okay, all I'm doing is just swapping x and y coordinates for these 2 points, right? The point 1, 3 then becomes the point 3, 1 for the inverse, and likewise here, the point 3, 7 becomes the point 7, 3 for the inverse. All right, how about the domain and the range of the inverse? We'll notice that since we're just swapping inputs and outputs, okay, we're then swapping domain and range. Now, I can see just from this picture, if I want to know what the domain is, we'll just project this green line segment onto the x-axis, and I can see I'm covering this interval from 3 to 7. So for the domain of the inverse, I'd say that x is greater than or equal to 3 and less than or equal to 7. And notice here, same interval, but I'm just swapping x and y. And then for the range, well, on this green line segment, the y values range from 1 to 3. So in other words, if I were to project this green line segment onto the y-axis, I'm going to be covering this interval right here from 1 to 3. So I'm going to write that as y is greater than or equal to 1 and less than or equal to 3. All right, well, that's going to do it. Thanks.